All right, we went through some rules yesterday. You have those out. We're going to review those before we get into doing these four. Real quick. I'll be calling on some individuals today to give me answers on these 15 that we have written out. Dylan, what's one of the rules you have written down? Okay, when we say significant, they are part of the measurement. So zeros, are they part of the measurement or are they just placeholders? So captive zeros are always part of the measurement, so you always count them. Any questions with that? If you've missed, there's an opportunity to get somebody's notes today. Probably take you 5 minutes to copy down with some examples on it. Kaylee, what's another one?
Trailing zeros with the decimal shown, the zeros count.
Yep. So if I see a decimal and I see it trailing some other numbers, 1 through 9, then all those zeros are part of the measurement. It's just a scenario like, yeah, if that happens, when I know it was measured. I know those zeros were measured. And so I need to count them as significant. They're important. Significant means they're important. If you're significant to somebody or significant other, anybody have a significant other in here? You guys know what that means, significant other? No, cat doesn't count. Boyfriend or girlfriend or husband, wife, okay, significant other. So significance important. It means you want to include it in doing your calculations. Right? That's what significant means. So that's what we need to do. So that's when it's significant. If it's followed by following a number to the right of the number, and also decimals. I see a decimal somewhere in that setup. Okay? Eli, what'd you have for ones that don't count?
Trailing zeros without a decimal don't count.
Yeah, trailing zeros, if I don't see a decimal and they are to the right of the number, we don't assume that they're measured, because the only way we can assume they're measured if decimals are starting to be used, and then we can't assume that. Maybe somebody just forgot to put the decimal there, but we can't assume. Jared, what was the last one that you have down that?
Leading zeros never count.
Yeah, leading zeros never count. They're not significant. They'll fall out. Right? So I'll come around, ask you guys what you have for an answer. Bree, what'd you get for 40.0 centimeters? Then you can give it back to her if you want.
I had 2.
How many?
2.
2. That in the first period they said 2 as well. And I think you're counting these first 2, but this zero's also trailing that number. So any zeros that are behind a number and we see a decimal, they all count. So this one should be 3. That was one that was missed because sometimes you think you got the decimal, now no longer is it trailing, but it's always trailing. Anything to the right of those numbers with the decimal shown, they always count. Casey, what did you get for the second one?
2.
2. This 0 is trailing. It counts. That's okay. You're just learning to use it. This isn't easy. This is not an easy concept when you haven't ever had it. And it's like we never do practices in math. You're right. You don't practice in math. As scientists, we get a little concerned about measurements, and we want to show an accurate answer based upon our measurements. So that would be 3. So it's okay to miss these now. It's like on the test, you don't want to miss it, and that'll be in a little bit. All right. Tesla, what did you get for 14,000 kilometers?
2.
2. Those are trailing zeros. We don't have a decimal. Logan, what did you get for 0.005900?
4.
4. These leading zeros don't count. Trailing zeros, decimal shown, count. So you would count them all. Okay. Whitley, what'd you get for 44,000 hertz?
5.
5. Decimal shown. They all count. So there's just little rules. There's only 4 you have to remember and use and apply, and that's what we're doing. We're applying them. Nathan, 0.65 milliliters. 2. John, 1.000 grams. 4. Tyler, 4.00 times 10 to the minus 6. 3. Don't look at this times 10 because it just moves the decimal. Alright, so this is still trailing zeros. We just want to look at this number here. So that's 3. He's right. Brendan, what'd you get for 1,200,000?
2.
2. Trailing 0. Alright. Sam? What's that last one? 1. Any questions? You guys are doing really good on these. I hope everybody is that's not answering, but from the answers we look like, it looks like it's a pretty good deal. Alright, this is one I need to explain to you, and I'm not going to have somebody answer it. If you have a count, the count is exact. So if I ask you how many significant digits, and it's counting involved. Alright? If it's counting, that's an exact number. Now sometimes you can estimate counts, like how many people live in the United States. Around 300 million. That's kind of an estimate there at that point. And then we can't really significant digits. When we get these large counts, then now we have to look at significant figures. But if it's a count like people in this room today, we got 20 people in this room, how many significant digits would you have if I put down 20 people? You would say how many? Well, if I put a decimal, it would be 2. If I had said 20, it would be 1. When you count, you don't talk about significant figures. It's only in measurements. Right? Also, conversions. If I have a conversion, like it says, if I say 1 meter over 100 centimeters, how many significant digits do I have in both those numbers? 1. So if I multiply a number, okay, or divide a number, and let's say I have a number that's 49.3, and I come over here and I get a calculation and I divide and it's 0.493. Later on we'll see we have to limit that answer to 1 digit based upon this conversion. Does that make sense? No, you can't limit your answer based upon a conversion or counting, like if you had to find an average. We'd have everybody in here weigh themselves. We get a total, and we divide by everybody in here, and we get an average weight. Our answer does not depend upon counting or converting. You'll see that in a second. So when we start using significant figures, you'll see that in a second. Why we don't use that when we are counting. So this would be an infinite number. We would say infinite number. What that means? It means it's exactly that amount. Okay, we're not estimating it. There's 20 people in here. It's exact. Right? Let's go on. You'll see that later on. Brittany, what did you get for the 19 number?
8.
8. Right. Adam, what did you get for 490? 3. There's a decimal there. If you didn't write a decimal down, I think it was probably better on the board I gave you yesterday. So 3. Michaela, what did you get for the 12 number?
7.
7. Right. And then, Thomas, what did you get for the last one? 4. Great. You guys got this down. So why do we count? Why do we go through and do that? It's not just to count. It's to allow us that when we do a calculation to represent the measurements that we have correctly. And so what I want to do is I want to share this slide with you, and it tells you a little bit about your answer and how many digits you need to have in your answer. So if we multiply and divide, it can change our number a lot, depending upon what we're multiplying and dividing. So we're going to limit our answer based upon our measurements. And we need to go through some examples to apply this statement. Right? So if you go ahead and write that down over the next couple minutes, we'll try to apply that statement. I'm going to write both these answers out. If you want to copy this down, you can. It's up to you. But I'm going to write both the answers out that comes on the calculator when I do the multiplication and division that's up on the board. What I'd like you to do is apply the statement that says your answer cannot have any more digits than the least number of significant digits in one of your measurements. So then you have to look at your measurements and go, okay, this one has this many significant figures, and then find it for each measurement. And then when you get an answer, you have to limit it to that same number of significant figures. Yes?
Is there a decimal in the 4? 0?
Yep, 4.0. Yep, 4.0. Would anybody like to share and answer what you think the answer is? Eli?
69.
69. Questions on that? There are 2, 3, 4 based upon our scenarios that we gave you. So I need to limit my answer to 2. And then I've got to round the 2 down, leave it 69. If it was 69 point, here's a good one. If it was 69.7, what would your answer be?
70.
70.
What do you have to do with the 70 though?
Good decimal.
Put a decimal. Because then somebody looks at it and they go, 70, that's only one significant digit. So you have to put the decimal. So they could get a little tricky. You got to make sure that when you write it, you look at it again, because that'll get somebody on a test or quiz, I guarantee. All right? The next one, anybody want to share an answer? Gary?
14 centimeters squared.
14 centimeters squared. Any questions on that? There's 2, and then there's 3. I'm not going to do the next multiplication division. I'm going to go past that one. We're going to go to adding and subtracting. I think everybody has an idea when you do this, you're using and counting significant figures when you do that. I need to explain how adding and subtracting is different, because it is different. Adding and subtracting is different. So go ahead and write down adding and subtracting and kind of the idea we want to use on that. It would not apply to that situation. So I just put the least accurate, and I think pretty much everybody will understand what we mean by the least accurate. So I'm going to put 2 answers down for this one, and then based upon the definition, we're not counting anymore. We're not counting significant figures. Students will get to this point and they'll go, this 14.7 has 3, 18 has 2, and 4.635 has 4. I'm going to have 2 in my answer. No. Okay? Now, it might come out to be that way, but that's not the reason. Okay? It's kind of like 50-50. Sometimes you'd be right and sometimes you'd be wrong just by chance. So let me go ahead and write the answers that would be generated on a calculator, or you doing the tabulation on paper, what it would be. And this first one would be 37.335. Okay, the next one would be 6.55, and they would be milliliters in grams. Now that's not the answer you probably should have on your paper when you're done. So on the first one, what's the least accurate of the three measurements? 18 grams. I can't go past the one spot. So my answer is 37 grams. Now by chance, I would be right if I counted significant digits, but that is not the reason why it's 37, is because I can only go to the one spot. And this next one, how far can I go? Karen?
To the 10th place.
To the 10th spot. That goes out only one place. This goes out two places. I can't go any farther than the 0.1. So that answer should be 6.6 milliliters. Everybody get that? All right. And then the last one, we'll give you one more of these. And I'll write the answer out. So how far can I go here? To the 100th. And then I round the other one up. So the answer would be 0.55 kilometers. Any questions? Does that make sense?
Oh, it's point.
All right. Think you got enough information. Let me go ahead and give you the assignment. I'll go ahead and write it up on the board. All right. Here's your assignment. Those have to do some significant figures to where you're doing them right. And so, page 48, number 1. Easy. Okay, and then page 60. $38. And 43. Oh, wait a second. Page 60. And then it'd be 38 through 43. All right. So do those for tomorrow. Give me a little time to look through these sheets I wasn't able to get through, and I'll bring these around and show them to you.